So I want to start this discussion off by talking about the basic building blocks of elements, which are atoms. Now, I'm going to quickly just go over, what makes up an atom, things of that nature, okay? You might know this information already, but I'm just going to go over it so we have something to build on as the videos go on. So, atoms are made up of subatomic particles, and there's 3 of them to be exact. Subatomic kind of gives it away that they're inside the atom. And so to illustrate this concept, I'm just going to go ahead and make a cursory drawing of an atom. So we have the outside, that's the nucleus, and then inside we have 2 types of particles, which I'm going to differentiate by using 2 different colors. So we have these little pink ones and these little blue ones, and then surrounding the nucleus we have these green ones. Let's start by talking about this one right here. This is an electron. Right, it's an electron. So, let's talk about an electron. So some of its properties include that they are negatively charged. Okay? And they have an extremely small mass. Now that's not to say that it doesn't have a mass, because it does. It's just that in comparison to the protons and the electrons, well, sorry, I guess I gave that away. In comparison to the particles that are inside the nucleus, the mass is very, very small. So next we're talking about, you guessed it, let's talk about protons. Right? So let's put protons down here and let's talk about what a proton is. Now a proton, when we remember it, is a positively charged particle. Okay? P for positive, that's when we remember it. It does have significant mass. Okay? And is inside the nucleus. Okay? Also, I should write up here, it's outside nucleus. Right? So our last particle, which is right here, is a neutron. Right? Let's talk about a neutron. You may be able to guess that the charge of a neutron is neutral. So no charge. It has significant mass. And it's actually slightly greater than the mass of a proton. Than the mass of a proton. And last but not least, it is inside the nucleus. So yeah, these are the 3 subatomic particles you have. So you have the electrons that are outside, and then you have the protons and the neutrons inside. Now another term that may be used to describe only protons and neutrons is nucleons. Okay? What that basically means is particles inside of the nucleus. So I'm going to write it up here. Nucleons equal protons and neutrons only. Okay? So, like an example would be, somebody could just ask you to define what a nucleon is or what particles make up a nucleon, and you would say protons and neutrons. So now I'm going to move on to the next part of, well, what should be the next part of your chapter, which is going into more detail about the masses of these different particles. So now we're going to go to a fresh page, and we're going to call this atomic masses. Now, there are certain like letters they use to denote things like atomic masses and atomic numbers. For atomic masses, they use the letter A generally. For atomic number, right here, they use Z, but this is generally to mean the number of protons. So this is your first lesson right here. Atomic number equals the number of protons in your atom. So if we were to go back up and look at our sample, and we see that we have 2 protons in here, that means you have an atomic number of 2. So Z would equal 2. So the way to actually calculate atomic mass, which is A right here, I'm going to rewrite that, which is A. This is how you do it. You do atomic number, so I'm going to abbreviate this, which is Z. So you're going to add, you take the atomic number and you're going to add the number of neutrons. Okay? So that's basically telling you your mass, your total atomic mass is the mass of the protons and the neutrons. Now, it might also be a little intuitive for you to know that, because the only 2 particles in the atom that actually have a mass are your protons and neutrons. So combine them, that gives you your mass. The way they write this for like a particular element, say we're going with like element, we're going to call it element X, and they're telling us that we need to denote on element X what's the mass and what's the proton number of element X. This is how you would do it. For atomic number, you would put it right here. Atomic number, which is Z, goes right there. And then we have atomic mass. Atomic mass goes right there. So I'm going to label that mass, and label this atomic number, and atomic number equals number of protons. So we've learned so far that the total mass equals the mass of the protons and the neutrons, giving us this value right here. And the way we get the number of protons is by looking at this value right here. Now you guys may be wondering, well, what about the electrons? So, like I said, the general rule is the number of protons equals number of electrons in an atom. Sorry, I wrote that so wonky. In an atom. Okay, now the reason is this. Atoms are neutral. Atoms are electrically neutral. Completely, the whole atom. And this time I'm not just talking about the neutrons. Atoms themselves are neutral. This is a very important thing to remember in the future, because you might come across a problem that gives you protons and electrons as different numbers of an atom. That's probably a trick question, to be perfectly honest, because they are electrically neutral, and this is why. Since your electrons, I'm going to write this right here, since electrons are negatively charged, what we do is we take the protons to neutralize the charge. In order for that to happen, the only way that can happen is if the protons and electrons are in equal amounts. So that's the reason why whenever we look at this number right here, our Z, our atomic number, which gives you the number of protons, we always assume that your number of protons and electrons are the same, because we are talking about an electrically neutral atom.